Hi class, we are on lesson 2, day 3. We are almost done dealing exclusively with radicals. The next lesson actually gets into real geometry topics, but for now we need to finish simplifying radicals, dealing with like terms. You should be in your workbook. All the notes are in the workbook. We're on page 7. So pause the video and get your workbook if you don't have it. We are going to look at question number 1, just wanting to know, are they like radicals? So if you remember from your algebra days, like terms are terms that have usually the same variable. So for example, x and 5x both have the same variable of x. Now if there's a plus y hanging out on the end, that y is not a like term. But if they are like terms, you can add like terms. Now just like this one, root 3 and 5 root 3. It's essentially what I just had up here, except for instead of x, I had radicals. So these ones, yes, are like radicals. If they have the same number under the radical, they're like radicals. The one right below it with root 7 and 2 root 5, since the number under the radical is not the same for both of them, these ones are not like radicals. So sometimes it's pretty straightforward like that, and then sometimes it's like number 4, 5 root 12 and 2 root 27. Sorry, I was making sure I wanted to do this one. So when I look at it, 12 and 27 are clearly not the same number, except we've just spent how many days simplifying radicals, and this guy can simplify. So that's what I got to do. I'm going to break apart that 12. I'm choosing to use 3 and 4. You could have used 2 and 6. And then I'm going to rewrite it. Now, I did not leave a ton of space for doing this work, but luckily I'm not going to do all these examples. So I'm going to write in number 2 space. So instead of 5 root 12, I have 5 root 2 times 2 times 3. And pairs make perfect squares. So the square root of 4 is a 2. There's already a 5 with the 2. And there's a 3 left over in my radical. So this first term of 5 root 12 is actually equivalent to 10 root 3. Now, a 3 is still not the same number as 27. I get that. But this guy also can break apart. So when I get this one broken down, it's all 3s. So I'm going to rewrite number out front. And instead of 27, it's made up of 3 times 3 times 3. And since pairs make perfect squares, a 3 joins our 2, and a 3 is left inside. So this guy is actually 6 root 3. Both of those are root 3s. Those are like terms in disguise. So sometimes you won't see them unless you simplify, which is part of the reason that you should always simplify your radicals. So now that we know which ones are like radicals and which ones not and how to get them to be like radicals, we can add. If they're like terms, you can add them. So for number 7, root 3 plus 4 root 3, that has the exact same number under the radical. Now, this is like saying I have a root 3 and then somebody gave me 4 more root 3s. I have a lot of root 3s. Specifically, there would be 5 of those root 3s. So what I did is I took this invisible 1 and I added 4 to it. Don't forget that there's a 1 in the front. And that's all we can do because 3 is prime. It doesn't break apart. 5 root 3 is our answer. So when I go to number 8, they both have a root 5. They're like terms. So I'm going to do what you did in algebra days and basically just combine like terms. Now this one I can't just talk about people handing me things because they're negative numbers and that doesn't make as much intuitive sense. But just like we did here where we just took 1 plus 4 and we said, well, now we have 5 of those root 3s. I did not change the like term. That will always be true. You'll never change that. You change the number out front. So what I'm going to do here, I'm going to still have a bunch of root 5s. Like terms stay like terms. If you add puppies to more puppies, you get puppies. You don't suddenly have a bunch of camels. So if I have root 5 and I'm combining it with a root 5, I have root 5. Specifically, I will have whatever negative 2 minus 4 is, or negative 6. So that's the answer to that one. So number 9, you look at this and you just think, well, those aren't like terms, and we can't do anything. Except 12 is not fully broken apart. 12 is made up of a 4 and a 3, which, by the way, I already broke apart a 12 earlier on number 4 of your notes. So we should already be expecting to find a pair of 2s, but I'm going to write out my work anyway. So pairs make perfect squares. Square root of 4 is a 2. I have a 2 hanging out front. There's a 3 left over who didn't get paired up. So 2 root 12 is actually 4 root 3. And I'm adding 4 root 3 to this. 4 root 3 plus 4 root 3. If I hand you 4 kittens and you already had 4 kittens, you have a bunch of kittens. If you already have 4 root 3s and somebody hands you 4 root 3s, you still have root 3s. You just add the numbers out front to figure out how many of them that you have. You would have 8 root 3s. So then number 10, which surprisingly is, yeah, this is the last one I plan on doing with you. We've got 2 things that are rather large numbers, and so we're going to look for simplification. They might be hidden like terms, and we just didn't know it. So I'm going to break apart my 18. I'm choosing to do 9 and 2. So I'm going to rewrite it. The negative 2 is still out front. Inside will be a 2, a 3, and a 3. Pairs make perfect squares. So since that's a 9, the square root of 9 is 3. Inside my radical is still a 2 because nobody paired up with them. There's still a negative 2 in the front, which means that first term was negative 6 square root 2. 4 root 50, when I break that apart, I'm going to use 5 and 10. 5 is good, but this is a 2 and a 5. So I'm going to write the number out front. 50 becomes 2 times 5 times 5. Pairs make perfect squares. Square root of 25 gives me a 5, but left over is my 2. That's a 20 square root 2. So we will be adding those because they are like terms. They both have a square root 2. So negative 6 square root 2 plus 20 square root 2. I'm still going to have root 2s. When you add like terms, they stay like terms. But now I'm just going to take negative 6 plus 20, and I get 14. And I apologize, I lied to you. We are going to do number 12. Number 12 has 3 terms. I see a 5 root 3, a 2 root 20, and a negative 5 root 3. So 2 of them definitely are already like terms. So I'm going to go ahead and combine those, and we'll just kind of see if there's anything we could do with the middle term. So temporarily, don't do this to your notes, but temporarily, I'm not going to look at that. So don't do this to your notes, but let's pretend that wasn't there. 5 root 3 minus 5 root 3, absolutely like terms. So a lot of people will just go ahead and put the root 3. 5 minus 5 is 0, so I'm not going to put anything, which means I just did this wrong. If I'm saying 5 root 3 minus 5 root 3 is equal to square root 3, that doesn't make sense. Let's talk about, I already said kittens and puppies. Let's talk about mice. I own 5 mice for some reason. Somebody comes and steals my 5 mice for some reason. Do I still have mice left? Do I have a mouse left? No. If you start with 5 and somebody takes 5, you have nothing left. And remember, when you have a coefficient of 0, it's 0, which means I don't need to write any of that. It's gone. Except for the 2 root 20. So essentially, these cancel each other out. I'm left with my 2 root 20. I'm going to break apart my 2 root 20. So I'm going to find 2, 2, and 5. So I'm going to rewrite the whole thing. There's still a 2 out front. My 20 becomes 2 times 2 times 5. Pairs make perfect squares. Number stays out front. Leftover guy is still leftover. So technically, you could say we have 0 plus 4 root 5, which means 4 root 5 is the simplified answer. So I wanted to make sure we talk about 5 root 5, sorry, that's a 3. 5 root 3 minus 5 root 3 is 0. It cancels, it's gone. It is not root 3. Very common mistake that students make.